Today, we will talk about ionic bonding and how to represent ionic bonding using dot cross models. Here is a picture from a textbook that shows the sodium atom and the chlorine atom's dot cross model. Notice that the sodium electrons are represented with X's, the chlorine electrons are represented with dots. So it shows you that the electron from the sodium gets transferred over to the chlorine, and then over here it shows that sodium's new outer shell, which is shell number 2, has 2, 4, 6, 8 electrons, and it takes on a positive 1 charge because it has lost its 1 valence electron. And chlorine has 2, 4, 6, 8 electrons. Notice that that X represents the electron coming from the sodium, and it takes on a negative 1 charge. We draw the Na positive and the Cl minus pictures together to represent the new compound that formed between sodium and chlorine, which is NaCl. An ionic bond, which is also called an electrovalent bond, consists of ions. The positive ion that loses its electrons and the negative ion that gains those electrons. The charge depends on the electrons gained or lost. The metal and the nonmetal are always going to have a noble gas configuration, which means that when they gain or lose electrons, their configuration of electrons in their shells will be the same as its nearest noble gas. The bond forms from the positive and minus attraction between the positive and minus ion. Ions have a regular repeating pattern, and there is a very strong bond between the positive and negative charges that form. So we are going to represent this compound, NaCl, using the Bohr model. So in order to sort of expedite the process, I am not going to draw the protons and electrons in the center. I'm just going to draw the symbols, but on your worksheet, you need to make sure you take it slow and draw write in the protons and electrons. So for sodium, actually I take that back. Let me go ahead and draw it in, because if I don't draw them in, you guys won't do them on the worksheet for me. So you're going to have sodium, which has 11 protons and 12 neutrons. This is for Na. It is in period 3, and so it's going to have a configuration of 281. So the top picture is going to show you the atom representation, and then the bottom picture below the orange line will show you the compound NaCl once they take on their charges. So chlorine is going to have 17 protons and 18 neutrons. This is chlorine. 1, 2, 3, 7, 2, 8. So here, this electron is going to get transferred over to that chlorine. So the NaCl compound model looks like this. 11 protons, 12 neutrons, 2, 8. Takes on a positive 1 charge. Chlorine, 17, 18, 2, 8, 8. And it takes on a negative 1 charge. The dot cross model. So the dot cross model, we're going to have sodium with 1 dot. Chlorine, we're going to represent using 7 dots. This 1 electron is going to be transferred over to the chlorine. So sodium is going to end up with an empty shell, and the chlorine is going to pick that electron up, represented by a different symbol, which is a dot, and it's going to take on a negative 1 charge. Okay? The dot cross diagrams show the outer electrons. The charge is spread evenly using square brackets and then that oxidation number in the upper right hand corner, and then the charge is on the upper right hand corner. So this is what the dot cross diagram for sodium chloride would look like. Let's take a look at CaCl2, the Bohr model. So let's do calcium first. Calcium has 20 protons, and it has 20 neutrons. It has a configuration of 2, 2, 8, and 8. And chlorine, because there is a 2 after the chlorine, it actually means that there are 2 of them. So let me draw 2 of them. We have 17 and 18. 17 protons, 18 neutrons. Its configuration is going to be 7, 2, 8. And then because there's 2 of them, I'm going to draw another one here, 2, 8, and 7. So what happens here is that there are 2 electrons here. One of them is going to fill this chlorine, and the other one is going to fill that chlorine. So to draw the Bohr model of CaCl2, we're going to have 20 protons, 20 neutrons in the center. We will have 2, 8, 8, and its charge will be positive 2. And the chlorine will have 17 protons, 18 neutrons, and its configuration will be 2, 8, 8, with a bracket and a -1. Instead of having to draw those 2 again, what we do is we put a 2 down here in the bottom right-hand corner outside of this bracket to represent that there are 2 of them. Okay, notice that the charges are still going to add up to 0. We have 1 calcium with a positive 2 charge. We have 2 chlorines with a -1 charge. So the charges still cancel out to the number 0. Let's take a look at the dot cross for this. So calcium has 2 valence electrons. Chlorine has 7. And the other chlorine here has 7. So one of those electrons is going to go here from calcium, the other one is going to go here. So calcium's dot cross is represented with an empty shell because it's lost those 2 electrons. And chlorine, you only have to draw this once, has picked up that electron from the calcium to take on a -1 charge, and then we put a 2 down here to represent that there are 2 of them. Let's take a look at MgO. MgO, magnesium Bohr model, is 12 and 12. 12 protons, 12 neutrons. Configuration is 2, 2, 8. This is Mg. Oxygen is 8 protons, 8 neutrons. And its configuration is 2, 6. So the Bohr model for MgO shows the 12 protons, 12 neutrons, losing this shell to take on a positive 2 charge. And then the oxygen is going to be shown with those 2 electrons being picked up by that outside shell to become 2-. The dot cross, Mg, represented with 2 dots. It does not matter if Mg has the dots and oxygen has the crosses or opposite. It just has to be 2 different symbols. This magnesium is going to lose its 2 electrons over here. So magnesium becomes positive 2. Oxygen is shown having picked up those electrons to become -2. And that is where we will end day 3.